Finally, we're going to do a question that's a bit juicier. So because it refers directly to worked example 3, it does mean that we're going to be taking some information from worked example 3. Now, I don't particularly love this because I don't think that that is an accurate depiction of what a question would look like in an exam situation, but we're going to do it anyway. Okay, so first things first, the average amount spent on lunch was between this and this. Determine the sample size needed to reduce the interval to plus minus 0.05 for 95% confidence interval. So we're given some information here that we're just going to plug into this bad boy, and then hopefully we'll rearrange it and we'll get what we want. Now, if I take this lower one, I'm going to use this formula. If I take the higher one, I'm going to take the one that adds something onto the formula. Because it's 95% confident, I'm going to be using 1.96 as our z-score. Okay, you can chuck that in your calculator and work it out for yourselves, because I would think that this and 90% are ones that you would want to remember. All the other ones are, take it or leave it. Okay, so here we go. First thing I'm going to do is work out our mean. Okay, now if I know that it's between this and this, what that's really saying is I determined some confidence interval. This is the mean in between the two scores. This one goes this direction, this one goes this direction. They are traveling in the same direction away from this thing. So that means that if I add them together, 4.43 plus 4.63 and divide it by 2, calculate the average of it, I'll determine what that mean is. Now, I'm pretty sure in the textbook they just take that answer from worked example 3, but you know what? We're going to do it the hard way because sometimes the hard way is fun. Okay, good. So we work out that it's 4.53, coincidentally, the same number we used in work example 3. So next thing we're going to do, we're going to start chugging and plugging into this. Now, the other thing we've got our z-score, we've got that. We want it to be a plus minus difference of this amount. So all that really means here is, it's not any harder. It just means you're going to be adding or subtracting. You want it to be from here plus 0.05 and minus 0.05. So let's work out those scores first. So we want our confidence interval numbers to be 4.53 minus 0.05 and 4.53 plus 0.05. That's going to give me a couple of numbers, and those numbers are it looks like I'm going to have to press the buttons for myself. Don't you hate that? 4.53 minus 0.05. That one's going to be 4.48. And the next one is going to be, change that to a plus, 4.58. All right, so now I've got some numbers there. So let's start filling it in. I'm going to go with the lower because, living my life today. So our mean, 4.8. We want that one to be equal to 4.53 minus 1.96 all over n square rooted, and our standard deviation is 0.23. Now, it's not stated in the question, but you have to take that from the other question to make this doable. Otherwise, you end up with two things, and we're not solving it simultaneously here. If you look in the textbook, this is one of the facts that they just give it to you, and this is also why they refer to work example 3. So there we go. Now, when I take this over there, bloop, I subtract the, and I am left with negative 0.05 is equal to negative 1.96, 0.23 over square root of n. Okay, now we're going to take this one over by division. Divided by 1.96, And now I'm left with, now we'll just leave it as exacts because I'm lazy. Okay, so 0.05, I'm going to cancel out the negatives, is equal to 0.23 over square root of n. Okay, so now this whole thing is a number. It's just an ugly number. You can have ugly numbers just like you can have ugly people. So let's just switch their places. So now I've got square root of n is equal to 0.23 divided by 0.05. Now, I put this in brackets in my calculator. This is how I made it work. You can do some other algebra moves here, but whatever makes you happiest, really. Take this over, square everything. Woo! And now you end up with the answer of n is equal to 81.29. Therefore, you need at least 82 people in the sample. Pretend like that made it into the screen. And we're done.